Hi there. My name is Kim Armas. I'm advised by Dr. Anna Lobo, and for my BlueSciCon talk, I'd like to share some of the work that I've been up to just for over the last month since I joined the program later than other participants. So with that in mind, my project is about analyzing simulated phase-dependent spectra of Earth-like aqua and land planets around M and K dwarfs. But for the purposes of this talk, I will only touch on the M's. So I'm interested in the spectra of planets around M dwarfs because of what they might tell us about their potential habitability. And M dwarfs are great targets for searching for habitable planets because of how abundant they are in the visible universe. They are also smaller, dimmer, colder stars with closer inhabitable zones, which makes planets around them easier to detect through transit and radial velocity methods. Uh, as these planets eclipse more of their stars and exert more of a noticeable gravitational tug on them. M dwarfs are also more likely to host smaller Earth-like planets with shorter orbital periods, allowing for more frequent observations, and their long lifetimes can also support life development. So I'll be discussing an aqua and land planet around an M dwarf with total solar irradiance of around 1360 watts per square meter, and an aqua planet around one with an irradiance of 1628 watts per square meter. And the planets I'll be discussing are synchronously rotating, so the illuminated region on the plots correspond to the day side of each planet. So we can see that for the aquaplanets, as the stellar flux increases, the climate warms and the day-to-night heat transport becomes more efficient, reducing day-night temperature gradients. And you can also see that both aquaplanets appear to have this eastward equatorial jet present, but that's something to explore by plotting winds at a later date. And for the land planet, the surface temperature and the upward long wave flux plot look quite similar to the short wave downward flux plot from the previous slide, suggesting that we are actually looking at the planet's surface, which is in contrast with the aquaplanets, where we are actually seeing more emission from their night side. And this makes sense when we look at their cloud coverage plots. So paired with the cloud coverage plots, we know that the substellar point should appear darker for these aquaplanets since you're actually looking at high clouds over that point. And on the night side, you are looking deeper into the atmosphere where low clouds are emitting at higher temperatures. And we can see that for the land planet, the cloud coverage is very sparse and only high up in the atmosphere. So you really do get to look lower into the atmosphere for them. Another thing of note is that for the hotter aquaplanet, there are substantially more lower clouds on both the day and night sides. Now, when it comes to the flux versus orbital phase plots, we can see that for both aquaplanets, there's a slight maxima at the western and eastern quadratures with a minimum near the substellar point. So the high clouds we see on the day side are not going to be emitting as brightly as the lower cloud deck on the night side, which creates that minimum in the observed thermal emission. Whereas for the land planet, there is a maximum on the day side centered around the substellar point, which is expected and more intuitive since this planet only has a few high-level clouds. So you're really looking at the surface of this planet. Continuing, when we look at the albedo versus phase, where albedo is only calculated from the day side of the planet, we can see that there is a tilting in the curves for the aquaplanets with slightly higher albedos observed at western quadrature, presumably because there are some clouds being transported to the west of the substellar point. And for the land planet, we expect that its albedo to be pretty flat as there's very sparse cloud coverage to interfere. And these are all very preliminary results. As I mentioned in the beginning, I would like to add more case stars to the mix, analyze more aqua and land planets, look at changing simulation presets, and even adding more plots like plotting winds, etc. So thanks for tuning in. Have a great day.